Ladies and gentlemen, I think we can start, otherwise we will be late for the lunch. So, welcome to everybody on the second session of the 13th Conference of Racurs. Let me first introduce myself. My name is Miklos Gross. I'm surveyor, photogrammetrist, and GIS expert. I had my university education in Moscow at the University Migaik. I'm working already more than 20 years at Eurosense, which is one of the biggest European company groups in our profession. It has 13 companies in 10 European countries. We do aerial photography, remote sensing, photogrammetry, bathymetric survey, and GIS processing. In the last 2 years, I was the vice managing director of the group. So this is my background, just to know. Now let's start the work of our session. I think the second session will be not less interesting than the first was. In the coming 1.5 hours, we will have interesting presentations of the leading scientists of our profession. We will hear scientists from Russian private company Racurs, from the Moscow University, from the University from Siberia, and from the professor of University of Hanover. The upcoming presentations are touching most actual, practical, and scientific questions of our profession. So I'm sure it will be interesting for everybody. So let's start with the presentation of the scientific director of Racurs, Mr. Sechin. He will inform us about the general trends of the development of digital photogrammetry and photogrammetric systems. So, Mr. Sechin, please give your presentation.
Добрый день. Большое спасибо.
Good morning. Thank you for your introduction, Miklos. My report to a certain extent will be a continuation or sequence to Gottfried Konechny, whereas Gottfried was speaking mostly about general trends in photogrammetry and photography. I will be speaking about the trends of those instruments or tools, as he called them on his slides, not all of them, but only the digital photogrammetric stations. We shall have some overlaps in our presentations, but I will approach it from a somewhat different angle, because our company, as it is known, is a developer of a digital photogrammetric station photomod, and it is interesting for us to see how other similar software stations, photogrammetric stations, are going to develop elsewhere. So what is the main driving force behind the development of these digital photogrammetric stations? There could be different drivers. First of all, that would be the new instruments for imaging, new sensors, aerial cameras, LiDARs, satellites, GPS systems, and IMU systems, etc., etc. Secondly, the second driver is the computer technology, which is an important component in the development of digital stations. We're talking about software here. Next come new algorithms. Out of the computer technology, I have extracted a separate component of network technologies, and naturally, we are keen on the user experience and wishes. And this conference, in fact, one of its goals is to hear the wishes and opinions of those people who use, among other things, our system. Now let us move to what is happening in the field of new sensors. If we look at how satellite systems are developing, all the most recent systems are equipped with RPC coefficients, and which create no real problems for photogrammetric processing or support. Like Viktor Adrov mentioned, usually it takes a month after new satellite images appear, and we already provide support for them in a month's time. What is important in this field is that the volumes of these satellite images are growing, not growing only in the number, but also in the quality and resolution of those data. And in order to process these huge volumes of data, we need special computers, special computer capacity. And as a rule, here we're moving on to the so-called cluster solutions to process satellite imagery. If we go back to aerial photography, naturally, there are such cameras as ADX, cameras from Leica company, or Vision Map cameras from Israel. We'll have a separate report about that, and they are quite specific, special cameras, and usually the manufacturers of those cameras, they do already the initial photogrammetric processing, and this there is no need to provide the support for those cameras. But what we see appearing in the market, like the cameras not only doing the central projection, but also simultaneous oblique imagery cameras, like you could see it on the Gottfried's slides, like SCD-30 oblique. This camera has 5 lenses. One of it shoots down, and others with the 45-degree angles, and simultaneously they can acquire images where you can see even the side walls of houses. If we start processing such blocks of data, we'll have certain difficulties or problems. We'll have to use other algorithms to look for type points and use a different rectification procedure, because we'll have a different initial approximation, which is absolutely different from what we used to have during the advent of digital cameras, when they just started to shoot with greater overlaps. There were no serious problems for photogrammetry there. Moving on to another important aspect, which is computer technologies development. If we look at how computer technologies were developing, say, since 1995 until 2005, we'll see no real breakthroughs in that regard. Well, operational systems could change from Windows 2005 until Windows XT and others, but all of them were 32-bit systems. A regular computer had an Intel processor or AMD processor with single core, although in 2004 new technology appeared which was called hyper-threading, like multi-flow processing, but it proved to be not really reliable. It didn't increase the productivity that much. So first Microsoft produces first 64-bit systems for Windows XP 64, and same year the company Intel manufactures first processors with Core 2 Duo, with 2-core processors. In order for any technology to be assimilated, it needs some time. If I go to a shop, I think, be it France or Russia or Germany or any other country, and if I look at what computers they have on their shelves, it will look like this, generally. You can see it in black here. I just visited a site of one of the well-known American companies. I clicked on the first computer that they offer. That's a home application computer. They have Windows 7 Home Premium, but at a 64-bit version. They have 4-core processor, IP5 and quad-core processor, and they have quite big memory there. What can it provide to program developers and digital photogrammetric stations? Until 64-bit systems appeared, one application in the Windows system had access only to 2 gigabytes of memory, but in order to process huge amounts of data like laser dots or dense digital elevation models, they need much more memory if we want to put all our data into the memory. And it is the development of 64-bit operational systems, which is happening over the past few years, is providing a new, unique boost to an opportunity to work with large volumes of data in photogrammetric stations. Secondly, we have multi-core nature of modern processors. Multi-core approach in terms of program development, and you can approach it from different ways. One approach would be to specifically develop our algorithms which could use simultaneously all existing cores. With this, an approach to the development of multi-threaded applications. Second approach, to use different cores for different processes, and to use different process. We can process one image in one core. On the second, we can develop orthophoto, and so on and so forth. This is multi-processor approach, and the multi-processor approach is especially useful in cluster systems, whereas computer cluster used to be something extra expensive, requiring separate power supply and cooling system, separate room. Now I visited a site, one of the Moscow computer companies, and here you can see a cluster which you can simply order through that company and buy it. It doesn't require anything special. It is just a box with a number of blocks inside and a small monitor, which is quite affordable at that. And using such clusters, you can implement a multi-processor calculation, and which would simplify and expedite your work. Of course, you can develop specialized, customized clusters, like we have a conveyor type of process, and you can use these clusters. If we visit a site dedicated to processing, very often you can see such a large, big motto called "Go Parallel." Let's do everything in parallel. What does it mean? It means that, for instance, this technology of parallel processing is of great demand, and can be put to very good use. Interestingly, 1 year ago, the company Intel offered new types of processors called Intel Phi. This is a technology called many integrated core system, and it is only 1 year old. But still, they're going to manufacture the second generation of this hardware. This is like a board you insert into your computer, and this computer all of a sudden has 50, 60, depending on the modification, of additional processor cores. And a new version, they will acquire new memory as well. So by inserting this board into the computer, you get a computer cluster, which will help you to very rapidly process our data without applying any special program developing tricks. This is just a simple cluster technology, fully based on Intel processors, which is in principle different from what was developing earlier, like different special calculations, special processors, like video Gouda technology that people discussed for many years. Moving on, let us discuss new algorithms. It's hard to discuss them. I will have dedicated reports about them, but Professor Konechny mentioned such discipline as computer vision. If we open the most recent 6th issue of the Manual of Photogrammetry and read the introduction to it, or can you please recall the most recent ISPRS meeting? There was a professor from Switzerland, Konrad Schindler, and indeed we see that on the parallel with photogrammetry, the universities were developing another discipline which was called computer vision, and which was addressing absolutely similar issues and doing the same things. Like, for instance, the manual that Mr. Schindler mentioned about photogrammetry He showed the introduction to the manual, and the manual and computer vision, they had absolutely similar introductions with even the sequence of tasks, although the authors were different. So basically the logical approaches were same. And we see trends, we observe trends in different universities, like in the introduction to photogrammetry, that some photogrammetry courses are substituted for computer vision courses. So basically they approach same things, but from computer vision, photogrammetry derives new algorithms, and whatever new happened over the past few years came from this new discipline. I still would, of course, split photogrammetry from computer vision, because for photogrammetry we need, most of all, a certain precision. Here we are doing different tasks, and we work with large volumes of data, unlike computer vision, where usually they do and implement different applied tasks. I will not speak about algorithms here. They include such popular algorithms as to build dense relief, different 3D algorithms, some kind of automatic vectorization using a cloud of points into a vector form for 3D GIS, geoportals, and so on. Moving on to network technologies. If you recall what networks we used to have in our company, we started by having separate computers. Then we had 10 megabit network, then we had 100 megabit network, and then 1 gigabyte network, and we see that we're lacking power, and we are going to switch to 10 gigabit system. But it's not important. What is important is that now access to internet is available to any home appliance. And if we look at what speeds are provided by internet providers like Internet, providers in Moscow routinely provide 200 megabits per second, which is a standard thing. It costs only 1,000 Russian rubles, 25 euros per month. And people are talking now a lot about the cloud storing and cloud processing of data. How much time do I have left? 5 minutes. And there is one photogrammetric company, I'm not going to name it, which decided to use this technology of cloud storing, cloud processing, and it offers to its users, well, actually users of UAVs, to upload their images not to the server, where this to upload all their images to the server where they're going to process all this data. But this technology so far is not that widespread, because everybody's afraid to upload it to some other country. If we take not UAV technologies but something else, the sheer volume of data to upload the data from a single flyby, well, they would need not 1 day but even 1 week, even with 1 gigabit speed. And this cloud technologies, you have one powerful server where you upload your data, and other data, auxiliary data, or users can be connected to it and process them. Actually, it's quite a viable technology. It's a viable situation. And what do we have here? If our data are stored on some powerful server, which could be a computer cluster, they would do all the processing there, and you will you'll connect yourself to this cluster using a simple connection client with some maybe stereo processing at best, but no real calculation, which can totally change the architecture of digital photogrammetric stations. I'm looking at the future now, and perhaps it will change also the principle of marketing. In other words, we're not going to sell the digital photogrammetric station as such, as an end product, but rather sell it as a service instead. And new networking technologies are making us do this. Another thing which is important, what we feel already, and what was mentioned at one of our previous conferences, is that we feel that digital photogrammetric station in itself is no longer that important because it must be interlinked with certain geodata databases and some geoportals. Because, for instance, you process data, you get your orthophoto, your vectors, your elevation matrices. Naturally, you will have to submit them to some geoportal where they're going to be used or visualized somehow. But another question arises, which we often have to answer. About a year or 2 years ago, we processed something. And then all of a sudden, we acquire data for the same area, like the town of Sochi. It is very relevant now for Russia now. Many people know about Sochi now. And quite naturally, if we have such a geoportal to upload data from these geoportals, those points and vectors for the current project to see and control the workspace on the new data, because not everything has changed, of course. And unfortunately, we're lacking such an integration, but we're going to develop these integration solutions in future. Naturally, I mentioned it already. What is also important for us is the user experience. Please, if you have any new ideas or comments, approach us, tell us about them. And in conclusion, hopefully I was within my 20-minute limit. These are the ideas which are going to see some interesting progress in future, which includes oblique cameras and images, transition to a 64-bit software architecture, cluster computing, multi-threading and multi-processing, some new automation solutions like transition from 3D clouds to 2D visualization, and integration with geo databases and geoportals, and client-server networking, perhaps for new systems. Thank you very much for your attention. Now I'm ready for your questions. Thank you. Indeed, your report was very interesting, and you made it within 18 minutes, I think 20. So we still have 2 minutes for questions and answers. Would there be any questions? No questions. Okay, everything was clear. I have one small comment or question. I heard about sensors, and I heard about computers, about algorithms. But I think another thing which is important is the carrier. Basically, everybody's fighting for higher and higher resolution, geometric resolution, and radiometric resolutions. Yes, indeed. Could you speak about this? Because there is some certain gap, because very often it would be useful to have an opportunity to interpret aerial photography, but not with such high resolution. Too high a resolution sometimes prevents to do our interpretation jobs properly. If we need to have big coverage, now it is very hard to find a sensor which could cover huge areas, vast areas, with a resolution of, say, 1 meter or 1.5 meters resolution. This is one small question or comment. Yes, obviously you're right. Another important thing is the depth of bits, how many bits per channel we have. If we take old photogrammetric stations, when they received as input data with a lot of bits, so they just cut them down to 8 bits. Now it would be bad. Nobody is going to do that. You mentioned that already. As far as sensors are concerned, unfortunately, so far, our company is not developing sensors, so it's hard for me to say anything about it. Again, thank you very much for a very interesting presentation.